to a little video about Target 4B where we're going to be transforming linear functions. Alright, number one, let's warm up by just graphing. So we're going to graph 2x minus 6. So we're going to start at negative 6 because that's our y-intercept. 2x is actually 2 over 1x, which means we're going to go up 2 to the right 1. Up 2 to the right 1. And we're going to draw a line through it. Beautimus. Number 2, f of x equals negative x plus 1. All right, well, I know where the intercept is. It's at 1, right there. Now, the negative x. What invisible number is actually in front of that x? Hopefully, you thought to yourself, it's negative 1, Gooman, and you'd be right. Now, negative 1 is also a whole number, and we can write it as a fraction, negative 1 over 1. This means we're going down 1 to the right 1. Let's do that. Down 1 to the right 1. And there's our line. All right, what we're going to do with these functions is we're going to transform them. So that means we're going to move them around. We're going to make them different. Let's check it out. First, let's look at vertical transformations, or translations. Now, vertical translations move a graph up and down, and you usually see them written on the outside. Now, this plus 6 means up 6. All right, first thing we need to do is graph the original function. So, negative 4 is my y-intercept, down 2 to the right 1. Beautiful. Okay. Now, what I want to do is move my graph up 6. Let's color code, because you know me. There we go. Up 6. All right. So I'm going to move each point that I have drawn up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to connect my original line and my new line. Hopefully you can see that we moved up 6. Cool. Onwards we go. Ooh, oh, fraction looks so scary, but don't worry. Fractions are good when we're graphing. I promise. It's better than a decimal. Okay, so we want to graph the original function and then transform it as a minus 2. A minus 2 on this outside means down 2. Cool? Let's graph the original. The original one starts at 5 and then has a positive 2 over 3. That means we go up 2 to the right 3. Boom. Down 2. Okay, each of the points we made, let's move them down 2 spaces. Okay, here's my original line. And here's my moved down 2 line. Hopefully you can see that we moved our graph down. Another transformation that we're going to look at is called a vertical dilation. Another way that I used to like to call it is a stretch or compress. So I think of it kind of like gum. You're stretching the gum or you're smushing it into like a piece of gum that you stick under the desk, but hopefully you don't stick under the desk. That's disgusting. Please don't do that. Anyways, this is going to be, number 5 is going to be a stretch. And that I know that because it has a whole number bigger than 1 in front of it. So this 2 means multiply the y's by 2. Just the y's. Okay? So our points are going to stay almost the same. We're just going to multiply the y's by 2. And I kind of like to write it out. It'll be a little easier for us to see. Okay, first things first, let's graph the original function. We start at 2. Negative 3x, that means we go down 3 to the right 1. All right, I'm going to write these 2 points down so I know what they are. I like seeing them. Our y-intercept was 0, 2. And then this, it looks like 1, negative 1. Okay. just the y's are going to get multiplied by 2. So this becomes 0, 4, and 1, negative 2. All right, let's do it. I'm going to graph those two new points, 0, 4, 1, negative 2. Yes, they're going to kind of overlap weirdly, but that's okay. Oh boy, this is going to look so weird. I'm going to do my best to draw this. But first I'm drawing my original graph, and then we stretched it. It became way more, the slope became more extreme. So if you think about skiing, it would be a harder hill. It would be almost straight down. So hopefully you can kind of see that we took that black arrow, that black line that we did, and we stretched it, and it became the purple one. It's kind of hard to demonstrate over video, but in person, I do a stretch. So just imagine me stretching, I guess. All right, number 6. Negative 3 times f of x. Ooh, okay. So this is actually two things. This is we multiply by negative 3. But this is actually a stretch and a reflection. You'll see. Okay, first, let's graph. We start off at our original at negative 3. X has a 1 in front of it, so up 1 over 1. I'm going to write those 2 points down. 0, negative 3, and then 1, negative 2. We are going to multiply our y's by negative 3. So my new point is 0, positive 9, 1, positive 6. Okay, let's plot those 2 points. 0, 9, and 1, 6. All right, I'm going to connect them, and hopefully you can see that not only did we stretch the line, but we also reflected it. All right, here's my original, and here's the transformed one. It reflected. You should see its slope is completely different. It's going down instead of up. And its stretch, it's more steep than the previous one. Do I have one more for us to do? I don't. I was so sure I had a number 7. I guess not. Well, that's about it. Be very careful how you're adding and moving things up and down. And how you're multiplying, especially for the dilations. Make sure to ask me or your teachers any questions you have. Otherwise, have a wonderful rest of whatever day it is for you. Bye!